Are aliens building gigantic power plants in space that can make entire stars disappear? Two studies find dozens of stars with such bizarre emissions that the researchers have come up with a bold hypothesis. Dyson spheres are used by higher civilizations to generate energy. These fantastic species can theoretically tap into the energy of the entire universe and thus secure infinite energy reserves. What happens when we find such spheres? Is this the first contact with civilizations that are far superior to us? The first study to look for possible Dyson spheres has identified 7 red dwarf stars that have unusually strong infrared emissions. These stars are located within a radius of 900 light-years from Earth and show up to a 60-fold increase in brightness in the infrared range. This means no less than that these stars are strangely 60 times more luminous. This effect can be caused by a special type of Dyson sphere. The researchers of the first study combined data from various astronomical monitoring missions, including Gaia, TMAS, and WISE. These large-scale sky mappings and scans provided detailed information about the movement and infrared radiation of the stars. By analyzing around 5 million stars, the researchers were able to identify all those that show unusual emissions that would match Dyson spheres. At the top of the list of telltale signals is infrared radiation, as Dyson spheres or Dyson swarms would absorb a significant amount of the star's energy and re-emit it as infrared radiation. The red dwarf stars discovered showed exactly this effect. These emissions were estimated to be at a temperature of about 25 degrees Celsius, which is consistent with the theoretical predictions for Dyson swarms. This seems low, but this form of alien power plant uses special cooling systems and only extracts directly usable heat from the stars. A Dyson swarm consists of many individual satellites or structures that orbit around a star and harvest its energy without completely obscuring the star. The stars themselves are visible, indicating that they are Dyson swarms and not complete Dyson spheres. It sounds like pure science fiction, because theoretically these swarms could also be housing units of an advanced civilization that either settles around a dim star, or the individual modules of the swarm are inhabited by creatures that run the power plant. This all sounds fantastic, but it could be reality. Now you're probably wondering, who came up with this idea? It was the Russian researcher Nikolai Kardashev in the 1960s who developed the Kardashev scale to classify civilizations based on their ability to generate energy. Later, the American researcher Freeman Dyson expanded the idea and presented concrete models of what such cosmic energy generation systems could look like. Dyson suggested that advanced civilizations could build megastructures known as Dyson spheres or Dyson swarms around their home star in order to use its energy efficiently. Dyson published his seminal paper shortly afterwards, in which he presented the theoretical basis and physical conditions of such structures. The researcher showed that such a structure would emit enormous amounts of infrared radiation that could be detected from Earth. The idea of searching for these techno-signatures was already born at that time. However, our technical possibilities were very limited. Only modern astronomical investigations, such as Gaia, TMAS, and WISE, have made significant progress and shown us interesting anomalies. And the James Webb Space Telescope is making significant progress in our search for other intelligent life forms in space. What types of Dyson spheres are there? Isn't it fantastic that we can theoretically construct Dyson spheres? We currently lack the technical means to implement them, but we could already prove the existence and possibility of such power plants mathematically. Freeman Dyson and some colleagues presented exciting concepts. To harvest the energy of a star, there is the concept of the Dyson shell, a gigantic solid shell that completely surrounds the star. We can be sure that this sphere would capture all of the star's energy. However, due to its rigid design, such a structure in space would also pose immense structural challenges and instability problems. The structure would be difficult to keep stable and would require enormous amounts of materials that may not be available or difficult to install in space. Slimmer and more effective is the Dyson swarm, which consists of a large number of independent satellites or solar collectors orbiting the star in a stable orbit. Of course, such a power plant is much more flexible and stable than a fixed shell. The collectors could collect energy and either use it locally or transfer it to a central point, and unlike the Dyson dish, the star would not be completely obscured. Even more interesting is the Dyson bubble, a huge collection of translucent structures that are held in position by radiation pressure from the star. With this power plant, aliens with the necessary technical know-how could use the radiation pressure of the star to maintain their position. However, simulations have shown that controlling the bubble structure would be difficult and the whole construct would be rather unstable. But in the end, we don't know what technologies other civilizations have that we can't even imagine in our wildest dreams. The Dyson network of interconnected structures that partially surrounds the star is a combination of rigid and flexible structures that allow for more stable and controllable energy production. Fantastic variations are possible here, and exotic forms of matter or conductors could make such a power plant almost invisible. If we remember that no species is really interested in turning off the light, such permeable spheres are more likely than the rigid and inflexible constructs. If you're thinking that it doesn't get any crazier or more incredible than this, then you'll be amazed at the concept of the stellar engine. This Dyson structure not only collects energy, but also moves the entire star. In the form of a bundled beam, the collected energy is moved in a specific direction, and with the help of the power, civilizations of the upper two levels or category 3 could navigate their entire solar system through their galaxy or the universe. 60 stars with potential Dyson spheres discovered. Can you believe that the number of stars with potential Dyson spheres is increasing every day? The first study, based on data from about 5 million stars, identified 7 red dwarf stars that are hot candidates for the first unambiguous discovery of extraterrestrial Dyson spheres. With the second study, researchers continued the investigations and focused on an even larger number of stars in an even larger radius. This time, stars of all spectral classes came under the magnifying glass. It's a scientific miracle because this study identified as many as 53 stars as potential Dyson sphere candidates. This means that the further we look, the more clues we seem to find. Scientists explain this phenomenon with improved search algorithms and ever better technical possibilities. With each round of searching, we know better what to look for, and the persistence of scientists is paying off. Take a look at the promising results. The first study found 7 stars in a radius of 900 light-years, with potential Dyson spheres in a radius of up to 6,500 light-years. There were already 53. How many star candidates that show signs of extraterrestrial power plants will we then only find if we search in even wider circles? Measured against the vastness of the cosmos, the number of possible candidates is overwhelming. The results of the first study would mean nothing less than that there are possibly 7 highly developed alien species in our direct cosmic neighborhood. Measured against the true dimensions of the universe, 900 light-years is a stellar stone's throw. We are looking more than 40 billion light-years in every direction, and according to the alarming results of the study, we must assume that there are countless highly intelligent alien races within this space. The second study also used data from the Gaia, 2MASS, and WISE satellites and some additional data sources to analyze the infrared emissions and movements of all known stars within a radius of 6,500 light-years. The goal was again to find stars with unusually high infrared emissions. The 53 stars discovered include not only red dwarf stars, but also larger stars, some of which are similar to our Sun. Scientists see this fact as proof that potential Dyson spheres can exist in a variety of star systems. The infrared emissions of all these stars are significantly higher than their actual luminosity class would allow. Theoretically, there are various possible explanations for these increased emissions. In addition to the possibility that these stars are surrounded by megastructures that collect their energy and re-emit it as infrared radiation, hot planetary disks and some other natural phenomena are also possible triggers for the additional infrared radiation. Despite these limitations, The results of both studies are intriguing. All researchers involved in the study emphasize that further investigations are now urgently needed to determine the exact nature of these anomalies. Observations with a much more powerful James Webb Telescope in the near future will determine whether the infrared emissions are indeed indicative of extraterrestrial megastructures or whether they have natural origins. Until one or the other is proven, these 60 stars remain potential candidates for extraterrestrial technosignatures. The observation times of the James Webb Telescope are much sought after. Webb is currently mainly concerned with clarifying strange phenomena in the young universe. Thanks to its unique technology, researchers are also looking for potentially habitable exoplanets. The telescope takes several hours or even days to analyze a star or a planet. Hundreds of research teams worldwide have already booked their observation times, and we will have to be patient until Webb can focus his ultra-sharp eyes on these 60 mysterious stars. When will we build Dyson spheres? With these results and prospects, who doesn't dream of finally seeing a real alien, or at least real evidence of their existence? The Dyson spheres are a lead we have picked up, and we continue to search for suspicious signals in the universe. With all these visions and ideas, the question may also arise as to how these species are capable of such unusual feats, and why they are capable to evolve to such a high level. Kardashev, who was one of the most recognized astronomers and space explorers of his time, recognized that our own intelligence has developed linearly to the ability to generate and use energy. In the beginning, there was the use of fire. Later, the power of fire was transformed into electricity, which we use to power our technological systems. The discovery of storage technologies and technical drives has further advanced our development. We are only at the beginning of this development and are therefore only at stage 1 of the Kardashev scale. We are working on advances such as faster-than-light propulsion for spaceships, the manipulation of space-time, and soon the first quantum computers will bring about a revolution. It seems logical that other species have already completed these developmental steps and have also developed technologies that sound like pure fiction to us today. Click the subscribe button now. New exciting videos are coming all the time.